Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the standard change in free energy for a reaction, but this time I'm going to use a different method. So in a previous video or the last few videos I've shown using this formula here. So I've showed that you can calculate the standard change in free energy of a reaction by calculating the delta H standard enthalpy of a reaction, subtracting from that the standard entropy of a reaction. You calculate that using the summing equations and multiplied by the temperature. So if you want to know how to use this equation and you haven't watched my videos, go back and watch those. But in this video, I'm going to use the method of using tabulated free energies of formation. So the standard energy changes of formation of different substances. So this is very similar, almost exactly the same way that you would calculate the enthalpy, the standard enthalpy change of a reaction using the standard enthalpies of formation for your different products and reactants. So and basically what that is this equation here. So the standard free energy change of a reaction is going to be equal to the sum, right? The sum of the products minus the reactants, right? So it's going to be the moles, the coefficients of the products multiplied by the standard free energy of formation. So that's of the products minus the sum of the reactants multiplied by their coefficients, the molar coefficients. So the molar coefficients N multiplied by the standard free energy of formation of the reactants. So reactants. And so this is the equation I'm going to show you how to use today. So in order to use this equation, you've got to use the tabulated information for the standard free energy of formation. So here in this table, I have the tabulated values for the standard free energy of formation for these substances in my equation. So I'm going to use these in this equation here. So let's begin. So products first, I have 3 products. So I'm going to have a square bracket so I can separate that from the reactants. First product is CO2. I have only one of those. So 1 mole multiplied by its standard free energy of formation. So that's going to be CO2 here, negative 394.4. So that's going to be multiplied by negative 394.4, and that's kilojoules per mole. Okay, so this is moles. Moles and moles are going to cancel out. So we'll end up with kilojoules in the end. So we're going to add to that our next product, which is water. I have 2 of those, so I'm going to multiply that by 2. And then the standard free energy of formation for water, gaseous, is negative 228.6. So negative 228.6 kilojoules per mole. And then finally, I have ozone. So I'm going to add to that, and I have 4 moles of that multiplied by the standard free energy of ozone. So 163.2 kilojoules per mole. And so this is my products. And then I'm going to subtract my reactants. So I got to put this down here because I don't have enough room. So I'm going to subtract out the reactants. So My first reactant is methane. I have only one of those, so that's going to be 1. I'm going to multiply that by its standard free energy of formation, negative 50.5. So negative 50.5 kilojoules per mole. And then I'm going to add to that the next one, which is ozone. So I have 8 of those. And I'll multiply that by its standard free energy formation, 163.2. So 163.2 kilojoules per mole. So now I have everything plugged into my equation. So all I need to do is just calculate it out. So if I calculate the products, I end up with, what do I end up with? Negative 198.8. So I end up getting negative 198.8 kilojoules. For my reactants, I end up getting positive 50.5. So positive 50.5 kilojoules. And then I add those together, and I finally get a negative 148.3. So negative 148.3 kilojoules of free energy. So this, from the tabulated values, this would be the standard free energy change of a reaction. And so at the temperature, so this is, I believe, standard temperature. Yeah, standard temperature 25 degrees. Let me write that down. So the temperature here is 25 degrees Celsius. So that means, since it's negative, this is spontaneous at standard temperature. And that's how you would calculate the standard free energy change of a reaction based on the standard free energy changes of formation of products and reactants that you would have to get from a table. So I hope this was helpful. If you like this video, if this helped you in any way, then please, please, please like the video. Hit that like button, share it with your friends, subscribe to my channel, hit that notification bell so you can be notified by all the videos I put out, because you're going to click all when you do. And also, finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.